Hello students, I am Dr. Reethiika Rathan, MDS, Assistant Professor from the Department of Oral Medicine and Radiology, Vinayak Mission Sankaracharya Dental College, Salem. Today, I am going to discuss on the topic radiation physics. These are the contents which I will be explaining in my further slides. Radiation is defined as emission and propagation of energy through space or a substance in the form of waves or particles. Atom is a basic unit of all matter and consists of nucleus containing protons and neutrons and electrons that are bound to the nucleus by electrostatic force. So, the atomic structure contains nucleus and electrons. Nucleus. The nucleus consists of positively charged protons and neutrally charged neutrons. So, the number of protons in the nucleus, it is termed as the atomic number, which is unique for each element. The total number of protons and neutrons in the nucleus of an atom is its atomic mass. The electrons are negatively charged particles which are present in the extracellular spaces and are bound to the nucleus by an electrostatic force. Bohr model is used to calculate the number of electrons to be present in each orbit. Like the arrangement of electrons around the nucleus resembles a miniature of solar system. That is, the electrons revolve around the nucleus in the path of orbits or shells. So, each shells are described as K, L, M, N, O and P. It is also described based on the quantum number, that is 1, 2, 3, etc. So, the maximum number of electrons in an orbit can hold is based on a formula called 2n square. So, this n is the quantum number. So, for calculating the number of electrons to be held in an K shell is by calculating 2 into n is 1. So, n to the power 2 is 1. So, 2 into 1 is 2. So, K shell can hold up to a maximum of 2 electrons only. So, likewise L can hold up to 8 electrons and M can hold up to 18 electrons. So, similarly, we can calculate the number of electrons to be present in each shell. So, next is the quantum mechanical model. So, this describes the electron within three-dimensional orbits. It is described based on the quantum number and the shape of the orbit. The shape is designated as S, P, D, F, G, H and I. Then the energy needed to overcome the electrostatic force that the electrons need to bind with the nucleus is termed as electron binding energy. The electron binding energy is stronger in the nearer shell, that is the K shell, and it is weaker in the outer shell area. Ionization. When the number of electrons in an atom is equal to the number of protons in its nucleus, the atom is electrically neutral. So, if an atom is neutral, in that condition, if an electron is lost, it becomes a positive ion. The atom becomes a positive ion, whereas the free electron which is lost becomes a negative ion. This kind of pairing of ion is called the ionization. So, ionization is of two types, that is ionizing radiation and non-ionizing radiation. So, ionizing radiation, the higher energy particles like X-rays and ultraviolet radiations have sufficient energy to remove an electron from their orbit. So, hence they are called as the ionizing radiation. And in contrast, if like visible light, infrared and microwave radiations have lesser energy, so they cannot remove an electron from their orbit. So, hence they are termed as the non-ionizing radiation. The nature of radiation is particulate radiation, electromagnetic radiation. Particulate radiation. Small atoms have equal number of protons and neutrons, whereas in larger atoms have more number of neutrons than protons. So, hence they are unstable due to the distribution, unequal distribution of the neutrons and protons. So hence they are easily breakable and they produce the rays like alpha rays, beta rays or cathode rays. Electromagnetic radiation. So this is the movement of energy through space as in a combination of electric or magnetic field, electric and magnetic field. It is the generation when the velocity of an electrically charged particle is altered. Examples of electromagnetic radiation is gamma rays, X-rays, ultraviolet rays and etc. This image shows the penetration power of each radiation. So gamma rays have higher energy for penetration and like it passes through the paper, then aluminum, then it is interrupted or stopped by lead, whereas alpha rays can be interrupted by paper, whereas beta can easily pass paper but stopped by aluminum. X-ray mission. X-ray mission produces X-rays that passes through the patient tissue and strikes a digital sensor or film to produce a radiographic image. So the components of X-ray mission is the control panel, extension arm and the X-ray tube head. The X-ray tube consists of cathode and anode which is situated in an evacuated glass envelope or tube. So this produces the X-rays from the cathode towards the targeted area in the anode region. So hence the X-rays are produced. So the X-ray tube consists of metal housing, insulating oil, tube head seal. The metal housing is made up of metal body. So the metal body of a tube head surrounds the X-ray tube and it also consists of oil. So this oil is an insulating oil which is used to absorb the heat energy which is generated during the X-ray production. The tube head seal is made of aluminum or leaded glass covering of the tube that permits the exit of X-rays after generation, and it also seals the insulating oil without leakage. Cathode. Cathode is present in an X-ray tube. So it consists of filament and focusing cup. So the filament is the source of electron within the X-ray tube. The filament is made of a coil of tungsten wire which is about 0.5 mm in thickness and length is about more or less 1 centimeter. So this filament lies in a focusing cup which is negatively charged and concave molybdenum bowl. The shape is of a parabolic shape which helps in focusing the electron towards the targeted area, which is a small rectangular area in the anode which is termed as a focal spot. Anode. The anode is present in the X-ray tube which consists of a tungsten target embedded in a copper stem. So the purpose is that the target is in an X-ray tube is converts the kinetic energy of colloiding electrons in X-ray photons. The focal spot is the area of target which the focus cup directs the electrons from which the X-rays are produced. There are two types of anodes, that is stationary anode and rotating anode. Stationary anode is nothing but the anode remains static in one position and is directed at an angle of 20 degree and the central ray is targeted towards that area. And rotating anode is nothing but it is designed in a beveled disc that rotates during the X-ray production. Power supply. Power supply has the X-ray tube and two transformers. The two transformers helps to provide that low voltage current to heat the X-ray tube filament and generate high voltage current to accelerate electrons from cathode to the anode area. The two transformers are step-up transformer and step-down transformer. The step-down transformer helps in reducing the voltage, that is normally 110 volt to 220 volt is supplied. So because of the step-down transformer, it is reduced up to 10 volt. Then when the machine is on and the exposure button is pressed, the voltage is increased up to 60 to 100 kilovolt because of the step up transformer. The X-ray tube controls. So those are tube current, tube voltage, timer. Tube current. So this helps in the flow of electrons from cathode to the anode and generates a current across the X-ray tube, and this is called the tube current. Tube voltage. The high voltage is required for the anode and cathode to give electrons sufficient energy to generate X-rays. Timer. Timer helps the high voltage circuit to control the duration of the X-rays to get to expose. Production of X-rays. Bremsstrahlung radiation and characteristic radiation. Bremsstrahlung radiation. As the term specifies, Bremsstrahlung means breaking radiation. So these photons are produced by a sudden stopping or slowing of high speed electrons by tungsten nuclei which is present in the target area. Characteristic radiation. So characteristic radiation contributes a small fraction of photons in an X-ray beam. So when an incident photon gets bombarded to the electron which is present in the innermost shell of the tungsten nuclei, so there the electrons get dissipated. So this produces an ionizing radiation. So factors controlling the X-ray beam: exposure time, tube current, tube voltage peak, filtration, collimation. Exposure time. When the exposure time is doubled, the photons generated are also doubled. So tube current, the effect of exposure time causes the quantity of radiation produced by an X-ray tube is directly proportional to the milliamperage setting. So tube voltage peak is by in case if there is increase of an X-ray kVp, an X-ray machine increases the number of photons generated. Meanwhile, energy of the photons has maximum energy of the photons. Filtration. Filtration is used to filter the low energy photons that does not offer any benefits for radiographic image to be produced, but it has some patient risk factors. So that's the reason filtration is used to filter the low energy photons and allow only higher energy photons to pass through the patient and received by the digital sensor or the film. So there are two types of filtration: inherent filtration, added filtration. In inherent filtration consists of materials that X-ray photons encounter as they travel from the focal spot on the target to form an unstable beam outside the tube enclosure. So this is made up of 0.5 to 1 mm of aluminum thickness. And added filtration is an aluminum disc which is placed in the pathway of the X-ray beam. So aluminum disc is made up of thickness 1 to 1.5 mm. So total filtration is nothing but inherent filtration plus added filtration. Up to 1.5 mm of aluminum can be used up to 70 kVp category and 2.5 mm of aluminum for higher voltages. Collimation. Collimation is a metallic barrier with an aperture in the middle used to shape and restrict the X-ray beam. So there are round and rectangular collimators which are mostly used in an intraoral radiographs. Inverse square law is nothing but the intensity is inversely proportional to the square of the distance from the source. The interaction of X-ray with matter. The X-ray beam enters the face or the region of patient area, it interacts with the hard and soft tissue and strikes the digital sensor or the film. As the beam goes through the patient, the intensity gets reduced. So this is called attenuation. There is absorption as well as scattered interaction. So coherent scattering is nothing but when a low energy incident photon bombards with the whole atom and there is momentarily exit of the incident photon. The photoelectric absorption. This process occurs when an incident photon bombards with the electrons which is present in the innermost shell and causes the electron to be dissipated. So through this the energy is produced. So Compton scattering. Compton scattering occurs when a photon bombards with the outermost electron in the orbit. This causes the outermost electron to coil around and move to another position. So that causes some radiation. The properties of X-rays. The X-rays are invisible, weightless, and travel in a straight line, and it is of a speed of light and has a wide range of wavelength and cannot be focused at a point over a distance, and beam diverges like the beam of a light, and it has a short wavelength that penetrates and absorbs or reflects visible light, and it also absorbs my matter and certain substances to produce fluorescence and produce biological changes in living cells, and can ionize gases and materials they penetrate, and cannot be reflected or refracted, and cannot be deviated by magnetic field. Uses it can be used in radiology like in dentistry and medicine, and helps to diagnostic radiographs to diagnose any pathological lesions based on the extent, size and the location. And it is also used in radiotherapy and industries. It is used for detection of radio valves, tennis balls and any tires if there is any defect in it. And in engineering areas, it is used to detect any cracks in the structures or holes. And photochemistry area, ionization of chemical producing, oxidation reduction, etc. So this image shows the production of X-rays. So when X-ray machine is turned on, the electric supply reaches the X-ray tube head via the control panel. So during this stage, the step down transformer is activated. So the voltage is reduced. So during that voltage is reduced, there is the energy is transferred to the cathode area, where there is electron formation, that is called the electron cloud is generated around the cathode area. Then when the exposure button is pressed, the voltage is increased based on the step up transformer, and this generated electrons is directed towards the anode, which is present in the opposite direction in the targeted area, and then the X-rays are produced, and which passes through the tube seal, filtration, collimation, and then passes on to the patient region of interest, and then towards the digital sensor or X-ray films. So this is the production of X-rays. Thank you for watching.